Are you ready to give Dead Rail a try? Calculating the maximum prototypical runtime before a recharge is necessary. Part 5. Calculating the initial maximum prototypical runtime per charge. To calculate the maximum prototypical runtime, you must be able to do simple math, that is, adding, subtracting, multiplying, and dividing by any means. A prototypical run means how you normally operate your trains. For me, I take an already made up train containing the number of cars typically used from point A to point C while passing through point B. Do some shunting at point C, including dropping off and picking up loads, and then returning to point A while again passing through point B. After returning to point A, more shunting is completed there and a new train ready to go to point C. For my prototypical run, I am not just running on a loop of track at full speed. I am moving at prototypical speeds and completing prototypical tasks. Whatever your maximum prototypical runtime ends up being, this initial run should be 30 minutes long, as 0.5 hours will be used to calculate the initial maximum prototypical runtime. 1. Start with a fully charged battery pack. It does not have to have been just removed from the charger to be full. It can have been charged a day or so ago. 2. Do the initial prototypical run for 30 minutes, which is 0.5 hours, and remove your battery pack. 3. Wait about 30 minutes for the voltage to stabilize a bit and rest the pack, and then charge the battery. 4. Charge the battery and note the highest return capacity in milliamp hours. Note, the return charger noted capacity will be more than the actual capacity removed from the pack. That's just the way chargers work. 5. Change the milliamp hours returned to amp hours by dividing the milliamp hours by 1000. 6. Divide the amp hours by 0.5 hours, and that will yield the average amp draw for 30 minutes of prototypical runtime. Determine the initial maximum prototypical runtime for your locomotive and your layout. 1. Multiply the stated label capacity by 80% to find the safe capacity. 2. Divide the safe capacity by the average amp draw. The answer yields the initial safe capacity in hours. Data for the following example to find the average amp draw. Stated battery capacity, 600 milliamp hours. Charger highest return milliamp hours, 150 milliamp hours. 150 milliamp hours divided by 1000 equals 0.15 amp hours. Runtime, 0.5 hours or 30 minutes. 0.15 amp hours divided by 0.5 hours equals 0.3 amps is the average amp draw. Finding the initial safe prototypical runtime for the example. 1. 80% of the stated capacity of 0.6 amp hours is 0.48 amp hours of usable capacity to be safe. 2. 0.48 amp hours divided by the average amp draw of 0.3 amps equals 1.6 hours. To change to minutes, 1.6 hours times 60 minutes in an hour equals 96 minutes. This is not the maximum prototypical runtime. It is the initial maximum prototypical runtime. This is the time to stop and check by recharging the battery to see if the initial maximum prototypical runtime can be extended or if it should be shortened. After the initial maximum runtime run, 96 minutes of prototypical running in this instance, recharge the batteries. Based on the highest return milliamp hours noted on the charger, adjust the maximum prototypical runtime accordingly. After several runs between charges, it becomes apparent as to what the maximum prototypical runtime is for your specific locomotive and your layout. The actual time will change slightly over time as the batteries age. It will also change if you start pulling longer and heavier trains than typical. My dead rail locomotives for reference. My layout is really a train table and it is flat. My typical trains are 6 to 8 cars long, not including the trailing battery car. IHC 280 consolidation using LocoFi and either 3, 10, 440, 350 milliamp hour IMR, 3, 10, 440, 320 milliamp hour INR, or 3, 10, 440, 280 milliamp hour IFR batteries, 1 hour. Both Walther's Trainline EMD 15-1s using LocoFi and 4, 14500, 600 milliamp hour IFR batteries, 2 hours. Athearn RS3 ready to run using Blue Nami and 4, 14500, 600 milliamp hour IFR batteries, 4 hours. I have provided a link in the description below to my article, How Long is a Typical Model Railroading Operating Sessions Runtime for a Single Locomotive? The article provides a more in-depth look at runtimes, including what others consider decent prototypical runtimes for non-dead rail trains. I have also provided links to my 4 dead rail conversions, which also notes their runtimes. Resizing the browser window, as shown in the screen capture, makes reading my website much easier. I suggest that my website should be checked at least on a monthly basis to see what I've learned, relearned, and where I'm going next with this project. In August of 2025, new and revised information was added to my website. If you have questions to ask or comments to share, my email address is linked at the top of my webpage. I would love to hear from you.